I'm live. Woohoo! This is Math 60. We're still in 7.4. We're working with multiplying and dividing, and today is dividing radicals and something called simplest radical form, which for something that calls itself simple, is not so simple. So let's talk about what division looks like. And division for radicals, basically, we have to go to fractions. So if I have radical 16 divided by radical 4, or the square root of 16 divided by the square root of 4, since each of these are actually, easy to simplify, radical 16 or square root of 16 is 4. Radical 4 or square root of 4 is 2. It's pretty straightforward. Bam, we're done. However, that's not going to work most of the time. So let's look at how do we actually approach this? Well, division is going to be in the form of fractions. And the thing about division is that we can smash these two together. So I can take two radicals and push them together to make a single radical. Having done that, 16 over 4, well, that's just 4. And radical 4 equals 2. So I get the same result both ways, but this way is not going to be a possibility most of the time. So we're going to have to go with this way. So you're going to have a bunch of options. Let's try. Divide and simplify. Woohoo! So first thing, I'm going to write out the division, then I'm going to take a look at what we've got. And I'm going to see that each of these radicals, each of these square roots, really is something I want to work on separately. If I combine them into a single fraction, there's nothing that would reduce. This is 16x cubed up top. This is y squared down on the bottom. There's nothing that they share. There's no overlap. So what I would do is work on each one separately rather than combining them. So 16x cubed, I'm going to remind you, is equal to, see, for bare math purposes, 4 times 4 times x times x times x. And again, bare math is great in the beginning, but I'm hoping that you will slowly move past it, but we can always have the bear here. Basically, if 4 makes it out and x makes it out, and there's an x left inside. Okay, take a moment if you're not sure, right, to actually confirm this, confirm that what I am saying makes sense. That the 1x gets left behind and 2 x's go running and 2 4's go running, and they come out as 4x radical x. Down in the denominator, honestly, this would be radical y squared, so that would be just y. And for this chapter, we're not going to worry about absolute values, but if you were, I'll remind you, I know there's just so much running around. There's so much running around that we have to remember when we're doing radicals. So remember that when you take the square root of x squared, you end up with the absolute value of x. Square root of y squared, you end up with the absolute value of y. For our purposes, we're just going to stick to this one. But it is possible that if you're watching this video, you may be in this land, which I understand is a land of hurt. But anytime you have the square root of a square, or the fourth root of a 4, anytime you have an even index, square root, fourth root, sixth root, eighth root, etc., you end up having to use absolute values if you're talking about all real values. So I do have a video on this. You can go back and look at that video to see what the heck I'm even talking about. For my students right now, this is the one that you're going to want to focus on for right now, because in this chapter, we're not going to deal with all real values. We're going to say X and Y are going to stay strictly positive. Another thing you would need to say is obviously Y can't be 0. And that might be a restriction you're required to say, or we just take it as an assumption. Y can't be 0. So there are a lot of things that we have to worry about in different settings. For what we're doing right now, we're just looking for the manipulation of the algebra, in which case this is really our focus. Okay, shall we do another one? Yay, let's do another one. So I've got radical 72xy all over 2 radical 2. Now, this one is great, except that it's a pain because I've got somebody outside the radical and somebody inside the radical. The outside guy has to stay outside. So this is the way I'm going to approach it. I write it as 1/2 because 2 is in the denominator. So we can't write it as 2. 2 is in the denominator, so it's 1/2. And then I've got this giant radical, 72xy all over 2. Let me get my handy dandy. I'm going to use blue to try to calm things down. Oh, it's weird. Sorry. That 2 is there in the denominator. Here's the 72xy in the numerator. And what I'm going to do, again, this 1/2 just hangs out. We're going to do radical stuff. So you just hang out. And it's actually very supportive too. You know, its friends all want to play radical games. It's not really into radicals, but it hangs out. It stays. It's a witness. It's supporting. Maybe it goes to get water, you know, whatever's happening. You know, it's on the sidelines going, yay, radicals, yay. So let's go ahead and see if we can reduce this, if this is useful at all to bring this 2 in. And what I'm going to suggest is it is, in fact, because this 2 can cancel with the 72 and leave us with 36. Okay, so I've got 1/2 on the outside being very supportive. And now I've got 36xy over 1. Okay, that's equal to 1/2. 36xy over 1, if it's over 1, I can just write it as 36xy. And then let's see the 36. Square root of 36 is 6. Okay, this is 1/2 times 6 over 1, radical xy. And now the 2 and the 6 cancel. And I get altogether 3 radical xy. Bam. Take a look at that. Obviously, I can't answer your questions right now, but if you have questions, text me, message me, you know, email me, and let me know, because this stuff gets pretty nasty pretty quickly. And having said that, hey, we're at 8 minutes, so you want to do another one? And I can't do my noise because YouTube thinks my song for danger is me swearing using the D word, and I am using the D word, duh, 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 not the other word. So I have to, oh no, ooh, maybe I will find someone to help me Foley this, and then I'll have it on my phone so I can actually play the sound. Okay, we're going multimedia. Woohoo, but not right now. I can't handle that many things at once. Okay, but if I could sing the song, I would sing it. First off, we got 4th roots. Then we got stuff like a to the 9th and b to the 5th running around. So far, so good. So what I'm going to do is you can approach this a couple different ways. Obviously, this numerator, the 4th root of 18a to the 9th. Oh, sorry, that's not a to the 8th. That's a to the 9th. B to the 5th. There's some simplifying we could do in here. However, this denominator troubles me. I know it troubles many people. This is a this denominator is so troubling. Let's see if I can find it. It even troubles Matt Damon. Matt Damon is troubled by this. Even Matt Damon. So what I want to do is I'm going to open this radical up and get these crazy kids together and see if they can brainstorm and come up with a solution. And the solution here is that we can totally cancel. This 3 goes into 18. We're left with 6. And this b goes into b to the 5th. We've got b to the 4th. Okay, so then we've got the 4th root of 6a to the 9th, b to the 4th, all over 1, which means I can collapse the whole thing. It just folds up to, a nice portable whole number sort of form. And now I can do the work of bringing everyone out, bear math style. So we've got a 4 bear. That's a really big one. And so that's what we keep in mind. This 6 is not going to be very helpful. It's just 2 times 3. Nothing much is going to happen there. But I do have 9 A's. 2, 3, 4, 5, 6, 7, 8, 9, and 4 B's. 1, 2, 3, 4. And again, some of you are already looking at 9 divided by 4 and 4 divided by 4. That would be awesome if that's the way you want to do it. However, if you're not sure what I'm talking about, then the other way to do it is you just take 4 A's and they go running. And here comes the bear. Nom, 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 nom. And one of them makes it out. These 4 A's go running. That's funny. Anyway. And one of them comes out. Sorry. Nom, 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 nom. He eats all the other ones. And let's see. 4 B's come running. Or I'm not sure. And one of them makes it out. The A is left, and the 2 and the 3 are left. So the 2 and the 3 and the A are left inside the cabin, and we tell them, don't worry, we will send for help. We don't really send for help. They're numbers. We don't need to. They're happy in there. The Wi-Fi comes back on. It's a happy ending. I mean, except for, okay, we're just not going to talk about all the rest of these, but, they're numbers. And it's a very happy bear. Nom, 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 nom. So that's how we do it. Woohoo. Hopefully that wasn't too horrible. Wow, look how far we've come. We were so innocent then. So what are we going to do? I'm going to make sure the indices match. The index on each one, they're both 4th roots. I combine them, see what cancels. Made it so that we add a 1 in the denominator, which allows us to collapse that fraction a little bit. Broke it down, square bear style, except this is a 4 bear. And you just have to 4 bear through it. Okay, never mind. And then we got our answer. Woohoo. So next video is the big time. I would encourage you to maybe, have a puppy standing by that you can pet, have friends and loved ones who are, available by phone. Simplest radical form and rationalizing the denominator is well known as the most traumatic part of an algebra class. So be prepared, have something yummy to eat and something nice to drink, and pictures of lovely sunsets or beaches or wherever your happy place is, and let's math on, guys. Woohoo.